This is a video on Green's theorem. The question states, a particle travels counterclockwise around a circle of radius 2 centered at the origin. Find the work done by the force field F of xy is equal to negative y cubed I plus x cubed j. So let's start by sketching this circle. Here's a circle. Its radius is 2, centered at the origin. I've drawn my little marks so that we see that the curve is going counterclockwise. And we have a region R, which is the disk that's bounded by the circle. So let's recall Green's theorem. And Green's theorem states that the line integral over a closed curve C that is simple and oriented counterclockwise of m dx plus n dy is equal to the double integral over the enclosed region of n sub x minus m sub y dA. So let's find n sub x and m sub y. We take the partial derivative with respect to x of x cubed and get 3x squared. And for m sub y, we take the partial derivative with respect to y of negative y cubed. And that's equal to negative 3y squared, and we're subtracting a negative 3y squared, so we get plus 3y squared. So we now know that the work is equal to the double integral over the region R of 3x squared plus 3y squared dA. We have a circle here, and the region is a disk, and we have a 3x squared plus 3y squared. This is better done using polar coordinates. So for polar coordinates, notice that the radius goes from 0 to 2, and the angle goes all the way around the circle from 0 to 2 pi. Also notice that 3x squared plus 3y squared, that's equal to 3r squared. And dA will become r dr d theta. So putting all this together, we get that this double integral is equal to the integral. Theta goes from 0 to 2 pi. R goes from 0 to 2 of 3r squared times r dr d theta. So to integrate this, the integral of 3r cubed is 3/4 r to the 4th. If you plug in 2, that's 3/4 times 16, which is 12. And then the integral of 12 d theta is 12 theta. Plug in 2 pi, and we get 24 pi. So we can conclude that the work done by this force field on the particle that travels counterclockwise once around the circle of radius 2, centered at the origin, is equal to 24 pi. And I'm done with the problem.